Hi, everybody. We are going to start the new section, which is AA. It's all about factoring. And I'm really looking forward to the quadratics, but we're going to start out with GCF of monomials, which is AA.1. That is the greatest common factor. That's what the GCF stands for. And in this particular case, what we're looking for, the big word here is the common. The common is the important part to pay attention to. So what we're looking for is we could factor both of these down to primes and then just look for everything that they have in common. That's basically what we're doing. So I'm going to go ahead and factor 6u squared. That is 2 times 3 times u times u. And the 9u is going to be 3 times 3 times u. Now what I've done is I've factored the 6u squared and I've factored the 9u. And what is common between both? Well, they both have a 3 and they both have a u. So 3u is the greatest common factor. One thing you want to do is practice this so that you can see that 3u will go into 9u and it will go into 6u squared evenly. There are no more common factors. So there it is. Hopefully you've seen this before and understand how that works. Let's take a look and see what the next one says. Now this one is going to be 2 times 3 times h, and the 3h squared is 3 times h times h. And notice that this one only has one h, but this one has 2 being multiplied together. But the common thing is that they both have 1 and they both have a 3. So the common factor is 3h. Now, some of you are going to be able to do this in your head. A lot of times the greatest common factor is the number itself. And notice that the 3w squared is divisible by 3w. And if you recognize that right away, 3w squared is divisible by 3w because it gives you w. That means I don't have to do the factoring. Clearly, 3 times w and 3 times w have these in common. So hopefully it's all clear and you'll be able to move right along on these. This section actually goes very quickly. Now we've got an x squared in both and we have a 3 as a factor in both. So it's 3x squared. Remember, you can always do the factoring if it's really complicated. In this one, there's a 2 that divides evenly into both factors, and there's also a z squared. So we're talking about 2z squared. And how about this one? Let's see what we have here. Now be careful. 6 and 8 only have a 2 in common because the 6 is 2 times 3 and the 8 is 2 times 2 times 2. And we also have a d cubed in both. So we're talking about 2d cubed. Looks like this one's going to go fairly quickly. Let's see, we have a 6z and a 2z. See, they both have z's and they both have a 2 as a factor. So it's 2z. In this one, oh, I see, we're supposed to factor it out. Okay, so we're supposed to factor out the greatest common factor. In this case, they both have a 6a, and this is a really good example. And here's what I'm going to do. I want to take the common factor between those two monomial terms, and it happens to be 6a, and I want to know, what do I need to multiply by the first term and the second term so that I get 6a cubed plus 6a. And this is the opposite of distributing. Factoring is taking them out. But what I'm doing is I'm thinking of distributing in reverse. I'm going to take them out. So I'm going to divide the first term by 6a. And you could divide it in both. That's one way to do this. You could take 6a cubed plus 6a, and you could divide each term by the greatest common factor, which is 6a. But I think that it's better to think of this as undistributing. So what do I have to multiply by 6a to make 6a cubed? Well, I need 2 more a's multiplied there. And what do I need to multiply by 6a to get 6a? I just need a 1. For me, it's easier to see it this way, but either one will work. Of course, if I take 6a cubed and divide by a, I get 1, and the a goes into a cubed and gives me an a squared. And 6a divided by 6a isn't 0, it's 1. So I get a squared plus 1. I think this is more intuitive, and hopefully you got it. This is, I didn't know this was coming, 6a, where's my parentheses? Answer the constant times the product of single variables. Oh, I see. We're just supposed to find the greatest common factor. We weren't supposed to, I thought they wanted me to write the whole thing. Sorry, guys. Got to read directions more carefully. All right, find the greatest common factor. Now there's lots of them. Well, one way to think of this is when you do greatest common factor, it is the least of all. So the factor that goes into all of these, the number is 6. 6 goes into all of those. And also x to the third power goes into all of them. So this is my greatest common factor because they're all divisible by 6, and the x to the third is the lowest exponent on that variable. So that's how you can think of it. I was going to do something else with that, but that seems simple enough. All right. Let's see. Okay, and this time they want 2h to the third. We want to find out 2 goes into both the 6 and the 2, and the h cubed is the smallest exponent. So 2h cubed. Notice that that does divide evenly into both. I won't get into more than what you want. I know you guys want to get through it. Okay, so this time we're looking at 4 goes into both and g squared goes into both. So it's 4g squared. Okay, this time we want d to the fourth. There's a d to the fourth in all 3 of those. And there's also a 2 in the first one. That's it. One nice thing is that if you ever notice that the first, like one of the terms, is a divisor of the other 2, it always works out like that. Let's see. We have a 2t to the fourth in both. Ooh, I said fourth. There we go. And we have a 4, a 13, and a 14. Now, this can be very confusing for people, but notice that the 4, the 13, and the 14 have no common factors other than 1. 13 is a prime number. That means if only 1 and 13 are its divisors. We're also looking for a factor that has a j. Well, the first one doesn't even have a j. So the greatest common factor is 1. One way of describing this is that we say that those monomials, those 3 monomials, are relatively prime. Now, they're not prime themselves because 2 times 2 is 4, and 13 times j obviously has factors, and 2 times 7 times j, again, the 2 and the 7 aren't primes. Well, they're primes, but the 14 is not prime. But we say that those factors or those monomials or those terms are relatively prime because they have no common factors. And we use 1 as its only common divisor. Hopefully that's clear. right, we've got a 13 that goes into all three, and the smallest exponent is the g squared, isn't it? 10 goes into both, and a to the fifth is the smallest exponent. And 4 goes into all three coefficients. We call those numbers in front coefficients. This is called a trinomial, and it happens to be 7th degree because its highest exponent is a 7. But for the greatest common factor, seems a misnomer, doesn't it? It seems like greatest should be the 7, but it's not. The greatest common factor is the one that goes into all three terms, and we're looking at the 4h squared. And what do we have next? Okay, 43 and 39 and 40. 43 happens to be a prime number. That's a big clue. 43, because it's a prime number, has no common factors with any other number. Like 39 is 13 times 3, and 40 is 5 times 2 times 2 times 2. They don't have any common factors in any of the coefficients. So the 1 is our leading coefficient, and the 43 has no W's. So they are relatively prime. One more time. Relatively prime means they have only a 1 as a common factor. All right. We've got 11 times 2, and 21 times 2 is the 42. 2 is the only common factor, and x to the 7th. Hopefully that's clear. This is 11 times 2, and this is 21 times 2. Just be careful. There are no other common factors, so it's going to be 2x to the 7th. They both have 7 x's in there. Okay. Oh, we're getting there. Not so bad. Hopefully you can see my little friend back there. I chose aardvark in case you didn't know. Aardvarks are spelled like this. And it was the only animal I could find with an AA to represent this section. Anyway, they all have a 12, don't they? They also all have 2 S's in common, and they have 8 T's in common. So we're looking for 12. They all have a 12. They all have at least 2 S's, S to the 2nd. And they all, I don't know if I need to go, yeah, I do need to go down. Okay, T to the 8th. 8 is the smallest t. So there's your common factor. We're looking for the smallest exponent on the s's, which is 2, and the smallest exponent on the t's, which is 8, and the common divisor for the coefficients. Man, that's a lot of vocabulary, isn't it? Don't worry. It's not so bad. It just takes a little practice. You'll be able to do this. Okay, we've got an 11 in both of them. And there are no A's and no B's in my second term. So 11 is my common factor. That's all I can take out. I just want to make sure that they're still looking for greatest common factor. They are. Okay. This time, notice that 4 is the best answer we can hope for. And you need to be careful. You need to make sure that 4 will divide evenly into all of the coefficients, and it does. But notice that this term right there has no n's in it, so it's just the 4. That's it. Oh, lots of things going on. Okay, so they all have an 11, don't they? This is 11 times 1, 11 times 2, 11 times 1, and 11 times 3. So they all have an 11. R's, there's an R to the 10th, an R to the 10th, an R to the 9th, and an R to the 9th. r to the 9th is the smallest exponent on the r's. And we have an s cubed, an s to the 4th, and an s to the 6th. S to the 3rd is the smallest of the s's. And this is our greatest common factor. 11r raised to the 9th, s raised to the 3rd. It's that easy, I promise. It's not so bad. You can do this. Okay, so I'll give you a second to look at those numbers. 23 is a very special number. Yep, 23 is a prime. The only number that'll have a common factor with 23 is 23. So if these are any other number, like 15 and 35, we say that they're relatively prime, even though the 35 and the 15 aren't prime numbers, but we say that these are all three terms are relatively prime. There are no x's or y's in that last term, so there are no greatest common factor is 1. Nothing to take out. Okay, we've got 5s in all of those, but we also have 3s. 15 goes into all of these coefficients. 15 obviously goes into 15. 15 goes into 45 3 times, and 15 goes into 30 2 times. So 15 is our common divisor for the coefficients. M, there is no M in that third term, so there's no M's. N's, there is no N in the second term, so there's no N's. There is a P in every term, and there's only one P in this second term, and that is the smallest exponent on the P's. So 15P is my common factor, and that needs to be taken out of all the terms if I were factoring, which we are going to do soon. All right, we have a 6, a 2, and a 4, and sure enough, 2 goes into all those coefficients, and there are no W's or V's for the 6 and the 2, so it's just the 2. And looks like we got a couple more. Almost done. 47 is, you guessed it, it's a prime number. 45 is 3 times 15 or 3 times 3 times 5, but 47 is a prime number, so, and there's no variables there, so it's just 1. We say those two factors or those two terms or those two monomials are relatively prime. And we have one last one. Okay, we have an 11 in every term, don't we? But notice that that middle term has no R's and no S's. So it's just 11. That's it. Okay, guys, I hope you got them all, and you'll go to your mastery medal, and I'll see you back for the rest. I'm really looking forward to quadratics. Bye, everybody.